All right, let's solve number 5. Okay, and we're going to prove that the limit of negative 15 minus 4x as x approaches negative 3 is equal to negative 3 using the epsilon delta definition of limit or the formal definition of limit. Okay, so again, we will be having 2 steps here. So here's our proof. All right, now, let me use my pen. Let me set up the pen. White. Okay, so our proof. So for the proof, now we are going to solve for, we need to solve for the delta here. All right, so solve for delta. Solve for delta. And we know that delta is greater than 0. So to solve for delta, by definition of limit, we have for every epsilon greater than 0, there exists a delta greater than 0 such that if the absolute value of x minus negative 3 greater than 0 but less than delta, then, okay, the absolute value of negative 15 minus 4x minus negative 3 is less than epsilon. All right, so here we're going to solve for the value of delta, and we will be using this given to solve for delta. Okay, so here, now let me rewrite the given. So that's negative 15 minus 4x minus negative 3 is less than epsilon. And here we're going to simplify. So this becomes negative 15 minus 4x plus 3 is less than epsilon. And simplify again, this becomes negative 12 minus 4x less than epsilon. All right, and let's move on to the next step. Okay, so the left-hand side again should be expressed in terms of this one. All right, it should be, or we can rewrite this in a form of, by simplifying this inequality, we have the absolute value of x plus 3 is less than delta. Right, so we need to express this in terms of x plus 3, absolute value of x plus 3 less than delta. So how do we do that? So for us to get x plus 3, then we can factor out negative 4. So this is negative 4 times x plus 3 less than epsilon, right? And we can factor out the negative 4 within the absolute value expressions. So that's negative 4 times the absolute value of x plus 3, okay, epsilon. And we know that negative 4, absolute value of negative 4 is 4 times x plus 3 over, less than epsilon. Okay, so let's move on to the next slide. So we have, our last step was 4 times x plus 3. Absolute value is less than epsilon. And again, we're looking for the expression which is x plus 3, or the absolute value of x plus 3 less than delta, right? So we can divide this by 4 both sides. So we have absolute value of x plus 3 is less than epsilon over 4. Again, we are trying to express this in terms of x plus 3 less than delta. So since both of them on the left-hand side expressions are equal, and both of them are less than, okay, they're less than, and we can say that by inspection, we can say that delta is equal to epsilon over 4. So this is now our value for epsilon. Okay, and let's move on to step number 2. All right, now in step number 2, we need to show that, okay, let's go back. We need to show that going from the, okay, from the premise of the statement, we need to show that this is true. So let's write that here. So step number 2, for every epsilon greater than 0, there exists delta greater than 0, such that if the absolute value of, okay, now let's go back here, this one. The absolute value of x minus negative 3, okay, is less than delta, but greater than 0, then, okay, so let's have the last statement or the conclusion. We have negative 15 minus 4x minus, and let's go back, minus negative 3 is less than epsilon. All right, so we are going to show that this is true, okay, or this statement exists. Now we are going to start, of course, from here, from this statement, the premise of the given statement, conditional statement, and we're going to show that this is true. All right, so again, our epsilon, sorry, our delta is equal to epsilon over 4. That's what we found a while ago. So now let's use this given, okay, in the statement. So that's 0 is less than x plus 3, which is less than delta. Again, this is always greater than 0 because absolute value means positive, equal or greater than 0, but can never be equal to 0 because x can never be equal to negative 3 since x approaches to 3. All right, so this becomes x plus 3 is less than delta, or the absolute value of x plus 3 is less than delta. Again, we need to express this left-hand side in terms of the left-hand side of this expression or inequality. So we have negative 15 minus 4x minus negative 3, something like that. Okay, so how do we do that? Now, first, we need to look for x here. The coefficient of x is 4, so, or negative 4. So we could multiply both sides by the absolute value of negative 4, right? So negative 4 times x plus 3 times, less than the absolute value of negative 4 times delta. Okay, so let's move on to the next. So we have, okay, we can combine this using the property of absolute value. So that's negative 4 times x plus 3, okay, less than 4 delta. Why 4 delta? Because the absolute value of negative 4 is 4. Okay, and let's simplify. So negative 4x minus 12 less than 4 delta. But then again, we should express the left-hand side in terms of this. Now, let's try to analyze the given statement here, or given expression. So there must be negative 15. So negative 15 minus 4x. And of course, if this is 12, this must be plus 3, right? Because negative 15 plus 3 is equal to negative 12. It's less than 4 delta, correct? Okay, so however, it is supposed to be written in this manner. So we have negative 15 minus 4x, and positive 3 can be expressed as a negative minus negative 3 less than 4, sorry, 4 delta. Okay, times 4. All right, here we go. Okay, so we have already expressed the left-hand side in terms of the left-hand side of the one that we're trying to express to, right? Or this one, the left-hand side of this statement. Okay, and we know that delta is equal to epsilon over 4. So 4 times epsilon over 4 is equal to epsilon. Therefore, we have already expressed negative 15 minus 4x minus negative 3 absolute value is less than epsilon. All right, so therefore, using the definition, okay, by definition, let me just erase this. Oh, it never be erased. Okay, let me write. Okay, let me write that well. So therefore, we could say that the limit of, okay, let's check the original. Negative 15 minus 4x as x approaches negative 3 is equal to, okay, I forgot, it's negative 3. It's negative 3. And we have already, since we have already proven that the statement is true using the definition of limit. So therefore, the limit of negative 15 minus 4x as x approaches negative 3 is equal to negative 3.